Square roots. You've probably seen before this symbol. That's a square root symbol. So the square root of x. And we also write it sometimes as x to the 1/2 power. But you'll, in this course, see it with the square root symbol. Your calculator can always find a square root, but it's not as easy for us to do it independently. So what even is the square root? If we think about addition and subtraction, those are inverse operations. Adding to is the opposite of subtracting to. And then multiplying and dividing, similarly, are inverse operations. Multiplying by 3 is the opposite of dividing by 3. So exponents, powers, also have an inverse operation. And for the to the second power, or squared, our inverse operation is a square root. So if you think about starting with a number like 7, if you did 7 squared, 7 times 7, you'll get 49. So if you wanted to go backwards in that problem, you started with 49 and you say, what number did I multiply with itself to get to 49? I'm going to take the square root of 49, and that's going to give me 7. So the answer to a square root problem is what number multiplied with itself gives me this number that I have to start with, right? Also, sidebar, that there are cube roots and all other kinds of roots, but we're not going to cover them in this video or in this course. So there are these lovely numbers that we call perfect squares, and perfect squares are the ones that are going to be easy to do in our head, hopefully. So 64 is a perfect square because there is a whole number that multiplies with itself to get 64. If you know that 8 times 8 is 64, then you can also hopefully see that going backwards, the square root of 64 takes you back to 8. So when you see perfect squares, you can do that square root in your head, usually. So like 2 times 2 is 4. So 4 is a perfect square, right? The square root of 4 is 2. 7 and 7 is 49. So the square root of 49 is 7. 11 times 11 is 121. So the square root of 121 is 11, right? These are just inverse operations. It is really helpful to make sure you know your perfect squares, at least up to 10 times 10, but 12 times 12 is helpful too. Let's keep going and see some more. So, square root of 36. If we are looking at a list of perfect squares, we will see 36 on there because 6 times 6 is 36. So I know that 36 is a perfect square and 6 is the square root of it. The square root of 100 is 10, right? Because 10 times 10 is 100. The square root of 25 is 5. And now stop for a moment and think if you know what the square root of 8 is. Is there a number that multiplies with itself to give us 8 nicely? And the answer is no, right? I can multiply 2 times 4 to get 8, but there's not a number that multiplies with itself to get 8. So this guy gets a little bit more complicated. It's going to have a more complicated answer. We'll see in just a minute how we do those ones when they're not perfect squares. Obviously, your calculator will tell you a decimal expansion for it, and you can use that if what you need is the decimal expansion. So whenever we have a square root that is not of a perfect square, our answer is going to be irrational. We'll talk more about what that means in a minute, but there's no nice way to write it out. If we do it in our calculator, we can get this decimal expansion, but an irrational number, which we're going to talk more about in a minute, the decimal never repeats and never ends. It goes on forever, and there's no nice pattern to it. So that's what we call irrational numbers. The square root of 8 is irrational, and almost every square root is irrational because there aren't that many nice, perfect squares. We will look at more of these as we go through. So if you know some of your perfect squares, you can estimate a square root pretty nicely. So for example, if I'm trying to find what approximately the square root of 65 is, I know that the square root of 64 is 8. So this is going to be a little bit bigger than 8. Not quite 9, because 9 times 9 is 81. So the square root of 65 is between 8 and 9, because 65 is in between 64 and 81. But this is definitely like a lot closer to 8 than it is to 9, because 65 is a lot closer to 64 than 81. We're going to do more of these estimations. So let's look at the square root of 11. I'm going to look on either side of that and think of what perfect squares I know. 3 times 3 is 9. And 4 times 4 is 16. Which means that the square root of 11 has got to be 3-ish. It's a little bit bigger than 3. It's not quite up to being close to 4 yet, because 11 is closer to 9 than it is to 16. So this guy's going to be closer to 3 than it is to 4. Yeah? The square root of 148. So 12 times 12 is going to be 144. And 13 times 13 is 169. And these I'm just using my perfect square list. You don't have to have these memorized. So when I'm trying to find the square root of 148, it's closer to 144 than it is to 169. So this is going to be close to 12. Not quite close to 13. It's definitely bigger than 12, but it's close to 12. Yeah? You need to be careful when you're taking the square root of negative numbers. Looking at this first number, we have square root of 100. We're going to do that first. It's 10. And then we have the negative on the outside. So the answer to this one here is negative 10. Use caution, though, when that negative is under the square root sign. If we are operating in the real numbers, which again, we're going to talk more about in just 1 minute, the real numbers, we do not have any answer for the square root of a negative number. So we say these are undefined. If you just decide that the square root of a negative number means something, then you just have a whole other field of mathematics. It's amazing. But what we're going to decide here is that the square root of a negative number is undefined. And here's why. If you had a positive number times a positive number, you're going to end up with a positive number, right? So the square root of 10 is 100. If you had a negative number times a negative number, you're still going to get a positive number, right? So the square root of 100 could be negative 10 as well, right? But there's just no way, if you had a positive and a negative, now you can multiply to get a negative answer. But now this isn't a square root anymore because these two numbers are not the same number. So we can't take the square root of a negative because we do not have a number that multiplies with itself to give you a negative solution.